Comes on everyone, let's start off. Great. So last thing that we did, we started with the potential energy. So this was the formula there. So if you have two particles and the distance between them is r, the potential energy is given by k, q1, q2 by r. So what this thing basically tells you, right? If you are trying to bring this positive charge from infinity, so if you already have one charge here, q1, and if you try to bring one more charge, q2, from infinity to a particular position, there will be a repulsion between them, right? So you have to do some work against this charge and you have to put it there. So all this work that you did gets stored in the form of an energy. So that energy is your potential energy. So that is one way to think of it. So it is the amount of energy required to assemble a system by bringing individual charges from infinity. And what if you have multiple charges, Q1, Q2, Q3? Then you take the energy of all possible pairs. If there are three things, then it is 3C2. If it is four, then it is 4C2, and so on. Right? So let's do one question before going ahead. So the only new thing you learned is k, q1, q2 by r. So instead of mgh or half kx square, all these are potential energies. We simply use now k, q1, q2 by r. The rest of the chapter will, the rest of the thing will look like just your work energy problems. So we got a triangle there, and there are four charges: q, 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 and q. This is the centroid. This is an equilateral triangle, side A. Then what happened? Someone took off these four charges and they assembled it again. So you have reorganized them in the form of a square. So you kept them on this thing, square of side A. Find the work done with external force to do the rearrangement. They initially have four charges, three on the vertices of an equilateral triangle and one at the centroid. You did something and you made them into a four charges on the edge of a square. Find the work done by external force to rearrange the charges. So initially, finally at rest. So there's no kinetic energy. So change in potential energy is work done. Let's get this. It's a simple, straightforward question on how to find the energy when you have more than two charges. How do we do this? And others, do we need to keep your cams on? Okay, so what you need to do, you need to find the initial energy of the system. So what is the initial energy of the system? So how many pairs are there? There are four charges, 4C2. So there are four pairs. So there are three side pairs and there are three pairs with the centroid, isn't it? So that's the total six combinations, 4C2, that is six. So you have K, Q, Q by A into three times. These are the sides. Plus K, Q, Q by, remember in the formula, denominator meter is an R, not square. Be careful. This distance will be how much? 2/3. So that's A by root 3 into 3 times. So this is with the centroid pairs. What about the final? You have 4 sides. So 1, 2, 3, 4, and 2 diagonals. K, Q, Q by A into 4 plus K, Q, Q by root 2A into 2 times. So these are the diagonal pairs. And these are the sides. You're done. So work done by external force is change in potential energy plus change in kinetic energy. Kinetic energy is anyway 0. So this would be simply U final minus U initial. Subtract, you'll get the answer. If you do this, actually you will notice you'll get a negative sign. The negative sign indicates you actually need not do work, but you actually get energy back in order to get this configuration. So the square is actually a more stable position than the triangle. Is everyone clear with this? So I don't think you'll get a pretty good answer. I think some you got something. 1 plus root 2 minus 3 root 3 or something of that sort. So you can check your calculations. You can handle this. Any doubts on this? All clear with this? Straightforward. So you just need to get the energy and you're done. So let's see one more. So we have a mass m here. We have a charge q. We have another particle here, 2m. This is fixed. And this thing ka charge is 2q. This is projected with speed u towards the particle. So this is very far. Find the minimum distance between them. A mass m, charge q. Is projected towards 2m head on. This thing is your Rutherford alpha scattering experiment ka thing. So the proton is alpha particle is going towards the nucleus. Find the minimum distance between them. This is an easier version. We will see cases of this. Because as you get closer and closer, they start repelling. At some point, you will stop. So what is the minimum distance of approach? Remember, the only new thing you learned is potential energy is K, Q1, Q2 by R. That's it. So after that, everything else looks like your work per energy, law of conservation of energy, everything is valid. Try, Param, give it a try. Just don't keep staring everyone on the screen. Everyone should give it a try. It's okay to get a wrong answer. If you're just waiting for me to answer and you'll just copy down or you'll just look into it, it's no point there. It's like watching someone swim and thinking, oh, now I know how to swim. Your senior ka bits is starting. Bits exam chalu ho gaya unka already. Most people have bits exam tomorrow. Please continue working. I know it is hectic. There must be a lot of backlog. Things are not good and all. That is the whole point. If everything was fine, everyone would have performed. So whenever you feel stressed and whenever you feel things are not going right, remember one thing. Not only you, everyone is going through the same thing. Everyone has their own kind of stresses and most people have backlogs. People are not able to handle everything. It's happening with everyone. So the one who will do well is not the one who is perfect. The one who will do less goof-ups will be perfect, will win the game. Right? So think of like that. No one is asking you to score 100% in advance or 100% in mains. Just think about it. If you score something like 180, 60% out of 300, that's still putting you 99 percentile. What does it tell you? No one is asking you to be perfect. So don't try to do like 100% I'll try to do. At least try to achieve 75 to 80%. That's it. You can do that. I think you're doing pretty well. Right? Even in advance, how much you think your seniors are scoring in mock papers? 45%, 50%, bus. Now, by the time the May 17th comes, it might bump up to 60. And 60% if you get an advance, that will put you in like what, below 1000 rank. So think that way. Getting it, no one is asking you to be perfect. Right? Out of 3 subjects, 1 subject थोड़ा backlog में चल रहा है, ठीक है. बाकी तो improve करते रहो, third subject maintain it. Once the revision gets over, you will get time. You can cover up stuff. But don't, become frustrated and irritated and stop studying. Whatever you can do, you do. There are 10 things to do, but you have energy only to do 3 things. Do the 3 things properly, na? Sir, बाकी 7 का क्या करना है? You can't do anything about the remaining 7. You have to accept it. There is no way out. You know what most people do? You have to do 10 things, but I can do only 3. They waste the time thinking about the remaining 7. They won't even do this 3 also. Overthinking, over planning, every week, worrying more and more about what to do about the rest, what to do about the backlog. Boss, you can't do it, right? It's accepted, right? You know you can't do it anyway. Then why don't you just do the 3 things which you can actually handle? Do it, right? That will give you bandwidth in the future to do the remaining 7. अभी वो 3 भी छोड़ने में क्या लॉजिक है? सर बट ये संडे हमारा टेस्ट है. Let the test go to hell ना यार. Let the test, seriously I'm telling you, let the bloody test go to hell. It is not helping you. You are just running behind that bloody test. Whatever is that your major test or that test. And see, there are some idiots here who missed classes last week saying like, there's a test and everything. And after 2 months, this chapter will be a backlog. Don't do that. Trust me on this thing. When I'm saying, right, have a little longer plan. Think about little longer. Like the next year, JEE mains first attempt is your longer plan. I know you have your pressures from your class. If you don't perform, they'll put you in the other batch, this batch, that batch. Somehow you need to get over this thing. I don't know how you can handle this, right? Unfortunately, right, I was lucky in that sense. I was really a wild kid and I didn't care about anyone, right? Anyway, I was always in the last batch, so I never had a problem. What more can they shift me, isn't it? मेरा टाइम में तो 3 ही बैच होता था. A, B, C, and C was the worst section that you can have. I used to be in the C section. So I was really carefree. I used to always sit in the last but one bench. I was fine. I was doing my work. I was getting things done. And no one had any expectations on me. I think the biggest advantage between you and me, you know what? No one thought I will pass. 100% sure. Everyone thought I'll fail. And that actually became the biggest advantage for me because means even if I do little more, I have exceeded everyone's expectation, isn't it? Upar se, I used to get pissed off because no one had expectations on me. I used to get angry because people are underestimating me. I wanted to prove them. And by chance, if I fail, people used to say things like expected. If I do well, they used to say he copied. Matlab, they are the only 2 options I always had. People had a level of confidence. When I got into IIT, you know what people thought in my area? People thought I got into ITI. You know what is ITI? After 10th standard, there is a diploma course for 3 years, Polytechnic, if you ever heard about it. So 10th के बाद एक option होता है, intermediate 11th and 12th, and they have something called a diploma course called ITI. It's a 3 years का Polytechnic course. That name is ITI. People thought I got into ITI Chennai. Almost for 2-3 weeks. And people have to ask me, for ITI you're going to Chennai. You didn't get in Andhra here. I said, nah, yaar. I'm so bad I didn't get it here. So, but seriously, I tell you, the way I could beat my friends and I can get a better rank or I can perform well is simple thing, right? I understood what is the most important thing for me. My most important thing for me is to crack the final exam. All your exams that are coming in the middle are just simple steps. If you can do well, great. If you can't do well, understand what is important and focus on that. I can't tell you this more than this. I'm looking at your seniors and I'm really feeling bad for most of them. Very good kids, kept a lot of work, but they wasted most of their energy thinking about your Sunday exam, Sunday exam, Sunday exam. And they forgot about the actual mains exam, which is going to come in January. Getting it. So you should have a little longer perspective. Please don't be so short-sighted. If you're only thinking about next week or next 2 weeks or next month, I'm telling you, you are not playing the game. You are doing something else. It's like you're being distracted by your classes ka tests every week. If you're not getting distracted, if they're helping you, great. But I'm talking about few people here. I see, right? There's a lot of pressure. Not your fault also. Abhi kare kya? I don't know how you will. take this ahead, but the people who can overcome this, who can actually look at a longer picture and say, next week, I'll give you a simple example. After 2 weeks, you have a major test. In that physics, mein, you have mechanics, that, this, everything. Sab mila ke 14 chapters hai. Right now, in this thing, you are okay, 6 to 7 chapters, you're okay. When I say okay, matlab, you're okay, you're confident में handle कर सकता हूँ. If you feel that way, there is no need to go and revise those chapters again. That is the meaning of confidence. What you guys try to do, you want to go and revise all 14 chapters. You become greedy. You guys are not optimizing for your resources. You have 2 weeks time. You have to study 3 subjects, right? You barely have 4 to 5 days per subject. How the hell can you do 14 chapters in 4 to 5 days? ऊपर से daily classes भी है ना. It's not a full day holiday. So into 4 to 5 days, you will get barely like what 4 hours per day. So we're looking at 16 hours for 14 chapters. How the hell are you planning to do 14 chapters in 16 to 18 hours? Why don't you just understand that one point there? And now what you're doing, because you want to do everything, you'll spend 16 hours on 14 chapters and you do nothing properly. In 14 chapters, if you're already good and 6 chapters, we still have to do 8 chapters. In 16 hours, right? I think you can maybe handle 3 to 4 chapters. So just focus on them, right? Make them strong, because next major test there'll be 18 chapters, isn't it? Next major test 18 hoga. But if you have done 3 chapters properly here, now next time you will say 9 chapters, I'm good. But you guys will waste your time doing nothing. Next time also you will say 6 chapters only. It will never improve. What is the point? हाँ सर, बट इसमें मार्क्स कम आएगा ना? या आएगा. So that's the price you have to pay. When you think long term, that's the price you have to pay for it. So I don't know, matlab, you guys can't get over this, and your chances of succeeding will drop rapidly. That's it. So I'm not saying some of you are really working hard. I see some of your reports. You guys put like a hell lot of work, right? So yeah, figure it out. I don't know, matlab. I know. All I can tell you is there is an issue there. Teachers don't cover stuff in lower batches, and they don't even complete it. So you have joined in other classes, right? So for physics, at least you have me. So some of you have taken support here and there. So you have to take a call on that. And I'm not telling you, abhi classes chhod do, wo kar lo, ye kar lo. But you guys need to see how it is working for you. Because this is seriously, I'm telling you. You might think like, oh sir, how can we do this and all? Everyone has their own agenda, including me. Keep this in mind. Getting it? Your teachers are, job is pretty simple. Your institute is only bothered about getting that top 4 or 5 rank so that they can put their poster on the page. I'm a physics teacher. I'm more focused on my physics. I really don't know what is happening with the maths and game. You're getting it? So whenever teacher says something, it might not be for you. It might be in general. Maybe the teacher got instructions like, like this. It happens a lot. Hota hai bahut bar, The management comes and tells the teacher, class mein 40 people are there. There are 6 people who are doing well. Are focus on the 6 people. Make sure to teach them well. Remaining people, whatever happens, let them go to hell. You guys don't know this, but trust me, when I was working in Hyderabad also, I used to work in Chaitanya Narayana there. Literally, the management used to call us on Friday. And can you imagine scolding teachers in front of everyone? Why is the student not scoring? Teacher ko scold kar rahe. We used to have indoor meetings that teachers used to get scolded. Like, why did that guy got 4 marks less? Seriously? And the teacher gives the explanation. Sir, that person is not feeling well. He has cold and all, so he couldn't perform. That's why he got 10 marks less. The teachers have their own pressures. Getting it? So I'll tell you, this is a true thing. We used to get an instruction like this. In that batch, we need all India first rank, or we need to get top 10 with 3 ranks. That's it. Remaining people, what happens? We don't care. Like you tell me, you give instructions like this, what happens? So you guys think about this, because see, you might get a 1000 rank or a 1200 rank. You'll get into IIT Bombay, but 1200 rank on a poster does not look good. No one gives a shit about your 1200 rank. But for you and me, it's a great rank. Trust me. So you ask yourself, what do you want to do? And because this is something I keep hearing a lot, like, sir, major test day, so I'll miss classes. Yeah, fine. Matlab, see, that's your call. I can't do anything like that. So you decide on this thing, because see, there's a limit to how much I can tell. End of the day, right? Frankly speaking, I'm your backup teacher. Getting it? So physics you're doing, you're having a problem. I'll be there with you till the end to take care of physics part. But overall, you need to find time to sit and solve. Anyways, so Because see, next year, by the time you guys realize what I'm saying now, it'll be too late if you wait till October or November. So बस वही बोल रहा हूँ. So think about it. अभी बैच कितना बार shuffle करेंगे ना, हो गया almost. And I'm sure anyway they'll finish off the portion in another 4 or 5 months. As if they care. They'll rush the portion and finish off everything. And they'll say we are done. And they have two reasons why they want to rush the portion. One, they want to finish off the portion early so that they can separate the toppers batch and train them separately, the 10 kids. So that they can ignore all of you. They'll give you some sheets and say assignment solved and you're done. Second, juniors have already started coming, isn't it? They need teachers now. They don't have teachers. So for your juniors, what they will do, they will have only 2 to 3 classes per week. Starting में आपको भी ऐसे होता था ना 11th में? You used to be very comfortable and happy, right? Weekly 3 classes. Very happy, no pressure, nothing for the first 3 months. And then suddenly classes became more. Did you notice? That's because 12th का portion खत्म हो गया था. Teacher is free, so dump them here and try to finish your portion because next year वापस juniors आएगा. That is the game we play. It's called resource management. They don't call me as a teacher anymore. I am just a resource. How much did we use the resource this year? Is the resource 100% utility is there? That is how my name will be there. My name will not be Arun Kumar, physics teacher. It will be physics ka resource. Resource 1, resource 2, resource 3. So, anyways, let's see how to do this thing. Please think about what I said, right? Think, but socho, ek do then you have time and see what is more important and focus on that. Your job, again, I'm telling you, you're serious for advance. First mains में 99 percentile score करना बहुत important है. 99 percentile in first mains, you need around 160, 170 score out of 300 in main. This should be your first target, not advance. जब तक mains पे 99 percentile नहीं आएगा first attempt में, advance का chances will drop drastically after this. There will be chances, but they will drop drastically. This is what I noticed over last 4 or 5 years. Simple reason. People who got 99 percentile in the first attempt, they will not care about the second attempt. Right? Second attempt इतना करने का जरूरत नहीं है. So entire Feb, March, April, May, 3.5 months you'll study only for advance. And advance ka preparation is different. You do really, really tough questions. You need time for that. Now, people who didn't do well in first mains, let's say you got 98.5. Your friend got 99.2. You'll feel okay? Now you want to prove yourself. I also can get 99 percentile. So you will prepare for mains 2. Option nahi hai tere paas. Now once you start preparing for mains 2 will get over by April 10th and result will come by April 20th. How much time is left for advance after this? 1 month. You can't compete with the guy who is doing advance for 3.5 months. That's it. Simple logic, constraint, lack of time. And if you do your mains ka preparation well, your bits becomes really good. This is one more thing. सबको लगता है bits easy है. Bits easy नहीं है. 130 questions in 3 hours is not a joke. And the cutoff is almost 290 out of 300 or 90 to get into bits Goa computer science. So you need to score really good. Last year, I think it was 285 or 283 cutoff for bits Goa computer science. So if your mains ka prep is not done properly, your bits ka chances also will drop. For some reason, people think mains चला गया, bits हो जाएगा. नहीं होता ऐसा. Getting it? So make your chapter strong. That is the whole point. So end of the day, not till more, but that is the whole thing. This is what I want to hear from you when we start our revision. October end or something, that's when we'll start our revision. If there are 24 chapters in physics, when I ask you how things are going on, right? You should be telling me, like, sir, in the 24 chapters, these 12 chapters, I'm good. When I say good, I can handle easy level, moderate level questions. Tak kar sakta hu. In this 6 chapters, I'm so and so. 6 chapters, I'm completely gone. If you can something like this, I think we can still handle this. Right? But if you come and tell me 24 chapters, 3-4 chapters, I'm very good. Remaining chapters, I'm not sure. I mean, you're gone. You might have done, but you're not sure. Right? So that is one. So what we will do now, I'll tell you something. So I made up something for this. You guys should do this. I'll send you this sheet after the class. This is the folder I'll share with you when the portion gets over. There, I made up a file like this. So what I did, every chapter I divided into subtopics. देखा vectors का, resolving vectors, parallelogram, blah blah blah. For example, look at rotational mechanics. Moment of inertia of standard shapes, parallels and perplexity theorem, calculation of torque, no slipping condition, rotation about fixed axis. So whatever I felt, I divided into subtopics. I'll give you an Excel file, so you can edit more, you can add more if you want. Now, what I want you to do, don't sit and do it in all one day, okay? You can do it little by little. So from the starting, start marking it. So vectors, resolving vectors, can you do? Yeah, obviously, I'm sure you can do. So mark it strong, a tick mark, strong, right? Parallelogram, you're fine, strong, and so on. For example, take a tougher chapter, let's say rotation. Moment of inertia of standard steps. I'm sure everyone remembers. Strong marker, calculation of torque, you can do, mark it. No slipping condition. I think I know, but I don't remember. Mark it as moderate or weak. If you feel I don't know, mark it weak. Right? Rotation about fixed axis, I think I can do it, moderate. Rolling motion, I can do, moderate. Momentum and moderate. Locating IR, this thing I don't remember, weak. Calculation of angular momentum, I can do. अभी देखा प्रॉब्लम ये है when people come and tell me ना my rotation is bad, when I ask them, you don't know how to do moment of inertia? No sir, I know. You don't know how to calculate torque? No sir, I know. You don't know energy? I know. You don't know rolling? I know. You don't know angular momentum? हाँ sir, हाँ I don't know angular momentum. Problem देखा? You don't know what is your problem exactly. So what you will come and say? You will come and say blanket statement. My entire rotation is bad. So to handle your problems, the first thing you need to know, what is your problem? When you know what is the problem precisely, you can go and attack that point and save your time. So this will be of your physics tracker. Getting it? So like this, you can mark it for every chapter. I did it for all chapters. Right? So isse kya hoga? 2-3 things will happen. One, let's say next time when you have an exam, 14 chapters ka, and when you want to revise, tell me one thing. So if you want to revise rotation, why the hell will you revise whole thing in the rotation? Just revise the things which are weak and moderate, isn't it? So this thing will save you time. You can do more chapters in a limited time. Problem क्या होता है पता है? When I tell you revise rotation, you know what you guys do, most of you? You'll open the notes, you will read moment of inertia. You will read torque. You will read rolling. You will read energy. You will spend 3 hours by the time you reach angular momentum. Then you need angular momentum, open it, you get irritated, frustrated, you are already tired, you do half an hour and you leave it. You spent 3.5 hours and you didn't do the most important thing which you're supposed to do. And आपको क्या लगेगा? मैंने 3.5 hours spend किया, फिर भी मेरा rotation strong नहीं है. Can you see the problem? You should have spent that 3 hours only on angular momentum or the things which you are weak at. So this, I'll send you the sheet. I don't have for other subjects. I made this on my own. So I'll give an Excel sheet. Maybe if you feel you can add more points on this. आपको लग रहा है you can divide rotation into more, divide it. That is up to you. So this will be a dynamic tracker. You're getting it? So every time you revise, for example, आपको लग रहा है IAR is weak. Put it in weak. Revise it once. Do 1-2 examples. Now you feel, I think I'm okay. Shift it to moderate. You're getting it? So your job is by December, when we give the mains exam, there should be nothing in weak category. Everything should be strong or moderate. Clear with this? So this is one thing I think it will really help you so that you will know what you know and what you don't know. You're getting this? So सोचो क्लास का बीच में आधा घंटा break है, right? And you want to revise viscosity. So सब करने का जरूरत नहीं है. You can just focus only on one topic, isn't it? So this way, when you categorize, you can spend 45 minutes on one small subtopic and you keep improving one at a time. Right? So I think this should help you. So I'll give you this. So please start filling it and start working on this and maintain this tracker. Okay, just don't do it like a one-time thing. There are total 30 chapters when I subdivided this text. Your job is this, right? And maybe that. Yeah. Did you revise the notes PYQ? So I gave this for your seniors. So for them, they have to fill up this tracker. So we keep this track of everything in November and December and Jan. But then I thought it is better if I give you early, because most of them couldn't fill this, in the end May, it became a little rush. So yeah, I'll give you the Excel sheet for this. So that will work for you. You can keep changing it. And this thing doesn't open, so big deal. So let's see, whatever I can help you with, I will try my best from my side. But there is right. So end of the day, it is all about you. All I can do is provide tools for you. Because I'll tell you something seriously. See, I really want all of you to go to good colleges. That could be IIT, BITS, NIT, or whatever. 2 years of struggle, itna mehnat karke, I just don't want you to go to any, just a regular college. अगर रेगुलर कॉलेज ज्वाइन करने हैं 2 years, यू कुड हैव एटलीस्ट हैड फन, राइट? इतना मेहनत करके एक्स्ट्रा क्लासेस अटेंड करके क्या फायदा हुआ? सो use your time. You still have time. The game is still not over, right? We still have 60% weightage in our hands. It can be still done. It'll be a little difficult, but can be done. So don't give up. Continue working. You never know what can happen till the last day. And I have seen miracles happening like that, right? People who didn't give up. There was a guy last 2 years back. उसका नाम क्या था? दिवी करके. Yeah, this guy, I first mains he scored 96 percentile. वेरी सिंसियर किड है, ऐसा टाइम पास वाला नहीं है, बहुत काम करता था. पता नहीं एग्जाम में क्या हो गया, 96.5 परसेंटाइल इन मेंस वन, राइट? And why I remember this guy so well, right? His dad called me after 11th standard and said, "Sir, in US, my relatives are there, my own sister is there, and I also have a subsidiary company there. So I'm ready to pay donation to a certain college there and get DB seat in US." राइट? सो इसको यहाँ पे 12th होने के बाद आई विल टेक हिम टू यूएस डायरेक्टली. यहाँ पे इंजीनियरिंग करने का जरूरत नहीं है. आई कैन डू दैट. बट दिवी इज नॉट एग्रीइंग टू इट. दिवी इज सेइंग इफ आई गो टू यूएस नाउ, एवरीवन विल से पापा का पैसे से मैं जाके पढ़ लिया. नो वन विल एक्सेप्ट दैट आई एम केपेबल ऑफ डूइंग एवरीथिंग ऑन माई ओन. सो दिवी सेज उसको इंजीनियरिंग इंडिया में करना है, बिट से आईआईटी में, खुद का मेहनत से. आफ्टर दैट बीटेक होने के बाद आई विल गो अब्रॉड. He's saying I will use daddy ka power, money and all, but not now. First, I'll prove myself I can actually do things on my own. And how do I do that? So by getting into a good college on my own with my own merit. The dad is saying, "Sir, ये तो पागल जैसा बात कर रहा है." Right? When I called that kid and asked him to US क्यों नहीं जा रहे, this is the answer he gave me. Sir, lifelong everyone will tell me, right? Because you have a rich dad, you are able to do all this. Even though I can work hard, I can do everything on my own capability, no one will trust me. My own dad will not trust me. Daddy abhi aisa bol rahe hai, but he will not trust me. He will always think like, because I was there, you're able to do all this. I will take his money, I'll go to US, but after I prove myself. This is what he said to me. Abhi main kya bolo bachcha ko. His dad again, and I had a conversation. I said, "Sir, you have a great son." Right? Yeah, this is the first thing I told him. You have a great son. Whatever he's telling, I don't see anything wrong in that. As a teacher, unfortunately, I do understand your point of view. His career will be much, much better, but there is no way I can convince him. If he says something wrong, I can tell him, "Boss, you're wrong." That guy is speaking truth. And that guy is saying something so noble, I cannot say anything. As a teacher, I'll support him. This is what I told the parent. His dad said, "ठीक है." After first mains, he got 96.5 percentile. Dad was feeling really bad. I was also feeling very bad. मतलब अभी क्या इतना कम हो गया. And ऐसा नहीं वो टाइम पास बच्चा है, बहुत पढ़ रहा था. I called Divya. I said, "Divya, are you fine?" He said, "ठीक है sir. I was a little disappointed. आना था, but exam में मैं panic कर लिया and all." I said, "ठीक है, don't worry. Let's continue and all." We continued working. Mains to me, he got some 97.7 or something. He improved, but still not up to the mark. This thing I keep telling you, mains to me improve करना बहुत difficult है. First attempt is your first target. Because mains 2 में at least, trust me, when 2020 से जब से देख रहा हूँ, I have rarely seen, maybe out of 100 people, 1 or 2 improve, or 5 people improve, bus. For some reason, it's very difficult to improve because you need a very high cutoffs. हो गया, getting it, and then he gave bits 1. He got some 267 or something. ठीक था, मतलब his dad called me, then we talked and said, हाँ sir, not really that great, but bits Hyderabad में कुछ ना कुछ मिल ही जाएगा. Advance he wrote, it really didn't go that well. He ended up something like 19,000, 18,000 rank था, but rank तो पता नहीं चला था. This guy, the best part about this guy, right? He didn't stop giving up. He continued working. Everyone stopped sending reports. This guy was sending reports. This guy was studying every day 10 to 12 hours. People got exhausted. Bits 2 में, he scored 329 out of 390. This will give you a seat in bits पिलानी computer science. मतलब that was like top. मतलब कुछ भी मिल जाएगा bits पे. I was more happy for him than I don't know how happy the kid was. I was more happy for them. पता है उसका exam 2 to 5 था. 5 o'clock I was waiting for him to call. Getting it 5 हो गया था. I called his parent. I said, "Sir, exam हो गया उसका? कैसा चल रहा है?" He's like, "Sir, अभी तक वो अंदर से बाहर नहीं आया." I said, "ठीक है sir, we will see. Once he comes, you tell me." I was really worried like यार इसको तो जाना ही चाहिए. His dad called around 5:10, 5:15. I said, sir, go 3:29. I said, yeah, great, yeah. I was really relieved, because I really saw his hard work. वो मेहनत था अलग ही level था. So I'm telling you seriously, people have done this. People have, you can beat this game with consistency. This is a game of consistent working. Sometimes you won't see the result, but don't stop working. And he got bits planning computer science. I said, अभी क्या कर रहे हो? They thought about it plus and minus and they joined bits Goa computer science. I said, क्यों? सर पिलानी ओल्ड बिल्डिंग है गोवा नजदीक है घर का नजदीक some bullshit reason. I said ठीक है, you're happy, your dad was happy, his dad was really happy. I said ठीक है, they wanted computer science and then at least now at least they don't have the regret of the US, so he will finish off his bits Goa CS and then he'll go abroad. जो भी है. I hope Trump will let him come in, but that's a different thing though. But I can tell you, everywhere you'll find people like that. There are multi people like that. So please don't stop working, right? Uh, formulate your strategy in that a way that you are looking little long term. If you play the game little long term, you'll have very good chances. So yeah. So I'll send you that sheet. Please start filling it up and let's see how it can go. So let's see. So how do we do this thing? So fix straightforward. So initially you're very far. This is state one. That means they're not interacting. This 2m is still fixed here. So this m will come somewhere here and let the distance be d. This is your minimum. When you come here, this is your v0. So this is state one and state two. So initially state, what is the potential energy? Potential energy will be zero because you're at infinity. What is kinetic energy? Half mu square. What is the potential energy? K q 2q by d. Kinetic energy is zero. Since there are no external forces on the system, initial energy is equal to final energy. Straightforward energy conservation if you see. And you get half mu square is equal to 2kq square by d. Solve this, you'll get d ka answer and that's the thing. Easy? Great. Let's see a variation of this. So what if the same question, this is not fixed, this is free to move. Can you do this? If the 2m is not fixed, but it is free to move. So what will happen if this charge tries to come closer, even that will get repelled and that also will fly off. Then what is the minimum distance between them? Even this year, two of your seniors got, first mains when they got 130 and 147. With second mains when they scored 193 and 197. They did improve a lot. So continue working. And like I keep saying, send your reports. That will help you a lot. I know I'm unable to reply from last 1 or 2 weeks. I became a little hectic. Wait for one more week. Let your seniors go off. Then you'll be the new seniors. Go. I'm waiting, Ray. I got irritated with them. पता है कल क्लास कितना हुआ? We started at evening 5 o'clock. It went on till what? I don't know, 10:30, 10 तक तो जा ही रहा था क्लास तो. Sometimes I'm taking class at 8:30 to 11 o'clock and they'll be sitting for doubts till 12:30 in the night. It's exhausting. Advanced doubts है ना, they take time. Mains का doubts नहीं है. They give me a question, so even I will take 4 to 5 minutes to read and understand and solve. And I'm also teaching them all weird stuff. So I was taking up INPH Olympiad questions and I'm teaching them. So I am trying to like literally like a harassment in the advanced revision class. It is fun for me. So I just give any weird concepts. I mix up everything. So there was a question like this recently. See, I'll show you what we did yesterday only. This thing. This was the paragraph. How does a particle interact with another particle? Have you ever thought about it? One electron gets to know the presence of another. Obviously, there must be some information exchange between the particles. The information exchange takes blah blah particles and everything. So there is something called Yukawa theory of intensity of strong forces. So this was a whole paragraph. I gave them 3 to 4 minutes to understand, read, and solve. This is an INPHO 2016 and 19 ka question tha. This is how they'll ask you advanced paragraph questions. They'll give you something completely new and looks weird, and they'll expect to read and solve it in 6 to 7 minutes. Right? Then this is what we also observed. I observed from a long time. Whenever the question looks more weird, it's actually in out of the two, one question will be very easy to solve. Even you guys can read this and solve. But anyway, we'll see that thing. And then we solved everything. And ye question yaad hai? The second part of the question, you know what? It was that SHM question which we did. The particle is going on a table, there's a block attached, yaad hai? Something of that sort. So we are doing Bohr's theory, as teaching them anything. We are doing collisions in atoms, alpha particle, oblique collisions, head-on collision. It is fun. So don't worry, we will be having two different revisions, mains revision and advanced revision. So let's get this thing. So what is the catch here? Now, if it is free to move, the story is the same. So initially you're very far. So eventually what will happen? This will be 2m, and this will be m. This will be your d minimum. So tell me one thing, when do you think the distance will be minimum? When both the things have same common velocity, isn't it? Doesn't this question look like two blocks with a spring attached between them? Can you see the relation between them? Instead of a spring force, we have an electrostatic force between them. Kind of, if you think about it. The electrostatic repulsion between them is like a big spring between them, kind of. So it feels that way. So as long as the guy behind is going faster than the guy in front of you, the distance will keep becoming closer and closer and closer. So that is the first thing you should realize, right? So when the minimum distance occurs, both the balls are the same velocity. So this question is similar to this guy, m and 2m, and this is u. So this will be vc and this will be vc. So max compression. So basically that's your minimum distance. Max compression occurs when velocity is same. So we can do the same argument here. So this is state 2, this is state 1. Since there are no external forces, we can conserve momentum. That would be mu is equal to 3m vc. We get vc is equal to u by 3. So that is the main idea there. It doesn't stop. And then we can conserve energy. Energy in state 1 is equal to energy in state 2. Initial energy half mu square. Potential energy is 0. Final kinetic energy of 3m v common square plus the potential energy k 2q by d minimum. Substitute there, you'll get d minimum. What is the faster way to do this? You guys remember how to do this thing faster? We say half mu v relative square is equal to half k x max square. Remember this concept? Reduce mass. So I can do that here also. So I can say half mu v relative square must be equal to k 2q by d minimum. Means whatever energy was going into the spring, that same energy was going into electrostatic potential energy, isn't it? Does Max know the difference between electrostatic force and spring force? Max doesn't care. So Max ko kya lagega? Someone has kept a big spring between these two. Instead of half kx square, there's a kq 2q by d minimum. So if you can actually compare like that, it'll be pretty easy to see. Are you sure with this? So that is how you can relate to this. Any doubts on this, what we did? So that is just a comparison with a spring block system, but even if you don't know that, you can still handle this. Let's see one more variation of this. What if we have this m plus q projected with speed u? We have another m plus q projected with speed u. The distance between them is a, and they're very far. What will happen as they get closer and closer, they start repelling. So this will go off like this, and this will go off like this. Find the minimum distance between them. So two charges of same mass and same mass, they're going opposite to each other, but not on the same line. There's a distance of a between them. So initially the distance is infinity, but as they get closer and closer, they start repelling. This shape is actually a hyperbola, but okay. Find the minimum distance between them. Let's get this thing. See, let's see how you handle this. Anyone not clear with the question, didn't understand the diagram, please ask. For this thing, for more reference, I will refer to its center of mass. You can check it out. This problem here, page 137. Let's see how will you handle this. Just get me the equation, sufficient. Okay, let's see what is the catch. I'll tell you something. Remember this thing. Whenever something red doesn't go in a straight line or something doesn't go in a circle, in physics 11th and 12th, there's only one way to do. Conservation of energy, conservation of angular momentum. Getting it? There is no other way you can handle this. So, when these two are moving, there is some guy who doesn't move. Who is that? Center of mass, isn't it? Since there are no external force on the system, the center of mass of the system will remain at rest. And if you notice this, so when the sphere is here and when the sphere is here, as they're moving, the repulsion force is always passing through the center of mass. Right? So the force, if you see, the repulsion force is always passing through the center of mass. Therefore, torque about the center of mass is zero. Since force between charges passes through center of mass, You can conserve angular momentum about center of mass. Always passes through comma. Therefore, torque about the center of mass is zero, and angular momentum about the center of mass is constant. That's the first thing. You can conserve angular momentum. And anyway, you can conserve energy. So now, if you look at the picture, let this be d minimum. So this will be d by 2. This will be d by 2. Let it be here. This is the center of mass. So two things again. The velocity must be perpendicular to the line joining them. Any idea why? The velocity must be perpendicular to the line joining them. Because if you have, suppose if the velocity is this way, then that means there is a component of velocity along the line joining them. That means they'll still get closer and closer. Are you getting this? So that's the second thing you should know. At d minimum, the component of velocity along the line joining them must be zero, or else they'll still get closer. You're done. So what is the initial angular momentum? L initial is equal to L final. Your initial angular momentum is mu a by 2. Remember, it depends on the perpendicular distance into 2 times. This will be mv. Let this distance be d by 2 and d by 2. mv d by 2 2 times. So you get u into a is equal to v into d. This is one equation. Next thing, energy conservation. Initial energy is equal to final energy. Initial energy half mu square, 2 times. There are two kinetic energies. Finally, half mv square, 2 times, plus k q q by d. That's your equation 2. So take v from here and substitute here, and you'll get the answer for d. Clear this? You'll get a quadratic. You take the positive root. Right, Samir? All clear the steps. This is your energy conservation. So equation 1 and equation 2 solve, you'll get the answer. Any doubts on this? So if you substitute here, this will end up with mu square. This will be mv square will be u square a square by d square plus kq square by d. Yeah, numbers are given, it would have been easy. So from here you'll get d ka value. Any doubts on this? All clear with the steps? Can you see how we played around this question? We said initially it is at rest, then we said it is moving, then we said they are not on the same line. In the first question, we did only energy. Second question, we did momentum and energy. Third question, we did angular momentum and energy. I hope you can see how all the conservations are coming up. Clear? So that's how you can play around with this. So you can still go on, but that's fine. I think for now, this much is good. Next thing, potential. Like I said, the same way, right? Instead of force, people preferred field. Why? We wanted to study per unit charge. So same way, people defined something called potential. Like I said, right? Scientists, right? They're really obsessed with studying everything per unit. So the potential difference is simply defined as the amount of energy required to bring a unit charge from infinity to a point. So if you have plus q charge, if this is point P, the distance is r. So if you're bringing a q charge from here to this point P, then we know the potential energy is k q small q by r. So the potential V is defined as potential energy by unit charge. So this becomes kq by r. So this is something people generally get confused. So just be careful. Force and field are one and the same thing, but field is per unit charge. Potential energy and potential are one and the same thing, but per unit charge. Are you clear with this? So it is like studying mass and density. Density is per unit volume. So people prefer to study per unit. So that's your potential at a point. So if you give a charge, and it is a scalar quantity, so potential at a point is given by k q by r. So this is the potential at point P due to charge capital Q. So what is change in potential energy? Change in potential energy will be charge into change in potential. Same thing. You're just writing the word change. So delta U will be Q into delta V. I'm sure you studied this in school, right? The work done by a battery or a force is charge into potential difference. So this is the thing which you should know. So when you want to find the potential energy, you can simply do Q into delta V. Example, let's say at point A, the potential is minus 10 volt. At point B, the potential is minus 20 volt, right? And you're taking, let's say, a charge Q, which is 2 coulombs. Let's say it is going from B to A. So the change in potential energy, UA minus UB, will be charged into VA minus VB. That would be 2 into minus 10 plus 10. That's 20 joules. Means if you want to take this positive charge from minus 20 to minus 10, you need to give 20 joules of energy. Clear with this? That's it. So don't get confused between the terms like, okay, what is force, what is field? Force and field are the same thing. Field is simply per unit charge ka force. Potential energy and potential are the same thing. Potential is simply per unit charge ka energy. Clear with this? So these are the four things we need to know. Force, field, potential energy, potential. So it's a scalar quantity, you can directly add it up. So there's not much. So let's do one or two questions on this and then we'll go ahead with integrations. That's the main thing today. So we have an equatorial triangle, we have plus q, we have minus 2q, we have 3q. This is side A. O is the centroid. This is point A, which is a midpoint. Find the potential at O and A due to the three charges. Remember, it is a scalar quantity, so there's no direction. You can directly add it up. So let's say we got a charge q here. This is d comma 0. This is minus q. 2d comma 0. This is again plus q. 3d comma 0. This is again minus q. 4d comma 0. And so on till infinity. Find the potential at the origin. Let's get these two questions. Hmm, first was easy. Get the second one also. I'll give you another minute, then I'll show you both. Second would be a pretty good mains question. The charges are alternating, plus minus, plus minus, plus minus, till infinity. So what about the first one? The potential at the center, VO, is KQ by distance, which is A by root 3, minus K2Q by A by root 3. You just add it up, और कुछ नहीं उसमें. K3Q by A by root 3. And you're done. Potential at A, that would be KQ, the distance will be root 3 A by 2, minus K2Q, the distance is A by 2, K3Q, the distance is A by 2. And you're done. You can simplify it, I'll leave it to you. What about the second question? You have charges alternating for every distance t. Right, Shriyansh, we have one answer. Others, try. क्या कर रहा है श्रीहरि 0.0693 and all. See, what is the potential? So this will be KQ by D minus KQ by 2D plus KQ by 3D and so on. If you take out KQ by D common, you end up with 1 minus half plus 1 by 3 minus 1 by 4 and so on till infinity. If you guys know, this is nothing but KQ by D. This is ln 2 ka series. Do you guys know the ln ka series? I'll write it down here. So this is the formula for ln series in case you don't know. Ln 1 plus x is given by x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on till infinity. This is ln ka series. If you put x is equal to 1, this becomes ln 2. And this becomes 1 minus half plus 1 by 3 minus 1 by 4 and so on till infinity. Useful thing, remember, again come across this in magnetism. That's your answer, kq by 2 ln 2. Most people will see ln 2 and then think like, what the hell, matlab, where the hell did you get ln from these numbers? Actually, what you get is a ln series. That's what makes the question good. Clear? So there, if you see, right, last two classes we spent time on finding field and potential due to point charges. We dealt with all point charges. Now we will take a break and then we will see up, all the, yeah, if you see the options, you'll get an idea that then we will start off with something, all continuous bodies, rods and arcs and everything. That will be quite important. So take a break, come back by 9:40, we'll continue from here. Go away from the screen. I'm giving a break to go out and look somewhere. Don't keep staring at the screen, Aditi. Go out and look at moon or something.
I was looking at the question again and reading it because I was trying to understand the answer more.
Chalo, hands on everyone. Now, whatever we have learned so far and everything, right, will be exact same replica in gravitation. So, like I said, if you're done with your electro properly, 80% of gravitation is done, and potential due to continuous charge distribution. So, the first shape we will deal with is a uniform rod. So, we got a rod here. Lambda. Now, be careful here. We will define few things. So, this is point P. L is the length of the rod, and this D is the distance from this corner here. So, lambda is your linear charge density. If you remember in center of mass, we used to call it linear mass density. So, find the field and potential at point P. So, we have a rod, and there's a point P at a distance D from the end of the rod. Find the field and the potential from that thing there. So, few terminologies again. Lambda is charge per unit length. We call this thing linear charge density. This can be variable also. In center of mass, we call it linear mass density. Then we call sigma, this is charge by area. The symbols will look same. This is called surface charge density. We use this for sheets. Rho is charged by volume. This is your volume charge density. We use this for 3D objects. So this whole rod has a charge density of lambda. And one more thing, be careful. Some people do this thing, huh? They take center of mass and they try to do it. Don't do that. It doesn't work. Center of mass works only for linear functions. We have seen that it works for pressure because pressure is P naught plus rho g x. So the question is the field linear here? The electric field is proportional to 1 by r square. This is not a linear function. Potential is 1 by r. It's not a linear function, so it doesn't work. So be careful. If the function is not linear, don't even think about center of mass. Because some people say like this, I'll put the whole charge at the center, I'll treat it like a point charge, and I'll find the field. That will give you wrong answers. Take a minute, then I'll show you one. So how do you take an element? So that's the whole story. How do you take an element and how do you integrate this? So we have a rod at a distance d from the edge of the rod. There is a point P. Find the field and the potential due to this rod. Okay, let's say I'll show you one. Remember, all the formulas we derived so far are valid for point charges. So this is point P. So at a distance x from point P, take a q by x square. Direction I cap.